Okay, today, first thing you need to know are the three phases of matter. What are the three phases of matter?
Solid,
Good.
liquid, and gas.
Good. Solid, liquid, and
Gas.
gas. Good. Okay. Now, the best way to know what a solid, liquid, and gas are is just how close the atoms are. Just like we were talking about earlier today, or yesterday, if we have three boxes, they're all the same. Okay? A solid is the most dense, like we talked about, so its atoms are really, really close together, right? Right? Really close together. Can you move the atoms of a solid very easily?
No.
No, you can't move the atoms. If I sit on a desk, is the desk going to shift around?
No.
No. Okay? What about water, liquid? Okay, they're kind of close together, but can you move them?
Yes.
Yeah, you can move them, because when you jump in a pool, if you couldn't move them, it would hurt, right? And then gas. Gas, the atoms are really spaced out. Can you move gas? Yes, very easily. Okay, you can move gases very easily. So the best way to see it is just to know that the atoms don't move in a solid. The atoms move easy in a liquid, but they stay together. Okay? In a gas, the atoms are free floating. Okay? So there's atoms of gases all around, right? What atoms of gases are in this room right now? Oxygen, carbon dioxide, nitrogen, right? Because what are we breathing in?
Oxygen.
Oxygen. So there's got to be oxygen atoms in the air. What do we breathe out?
Carbon dioxide.
Carbon dioxide. So there's definitely got to be carbon dioxide atoms in the air, right? Okay, so does everybody understand? A solid, they're close together. The atoms don't move. And the liquid, the atoms move easy, but stay together, right? Because when you pour water on the floor, the atoms still like to stay together, right? Typically, you're just going to have a puddle. They don't just go everywhere, okay? And then gases, the atoms are free floating. Free floating. Okay? So in a gas, the atoms are free floating. So we need to know these three phases, and then we're going to talk about the physical change, about how they go between them. Everybody got that? Hopefully. Okay? So what we're going to do is we're going to talk about a physical change versus chemical change. Okay, so you need to know what a physical change and a chemical change are. So first, what is a physical change? How would we describe it?
It looks different.
Okay, change in appearance. Good. Okay, change in appearance. What else is a physical change? Can you change it back? Good. Can be reversed. Okay, or changed back. Okay. So if I saw a desk in half, is it still a piece? If I saw a piece of wood in half, is it still a piece of wood? Yes, it's still a piece of wood. So, but could I put the pieces of wood back together at some point? Yeah, I could put them back together. So that's a physical change. So if you saw a piece of wood in half, that's a physical change. Okay? If I take a balloon that's been aired up and I squeeze it and I change the shape of it, is it still a balloon? Yeah. So that would also be a physical change. Okay? Now, versus a chemical change. How do we describe that compared to a chemical change? Huh? Well, what is a chemical change?
Change.
Instead of having just a change in appearance, what do you have?
Change in.
About a new substance, right? New substance. Can you change it back?
No.
Good. Cannot be changed back. Cannot be changed back. Okay, and we'll talk about some examples of chemical change in just a second. Now we want to come back, focus back on physical change. So examples of physical change. Examples. One example I want to talk about is melting. 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 Think about the phases of matter. What is melting?
Solids.
Okay, good. Going from a solid to a liquid. Good. So from a solid to a liquid. And if you think of it water, you can go from ice to water. Is it still water even though it's ice?
Mm-hmm.
Yeah, it's still H2O, right? So you're going from solid, frozen water to liquid water. The next one we can do is evaporation. And evaporation is going from what?
Solid to gas?
No.
Liquid to gas?
A liquid to a gas. Good. From a liquid to a gas. Okay? So that can go from water to water vapor as an example. Okay? Now, after it evaporates, you can have it condensation. Condensate. What's condensation? It's going from a gas to a solid,
To liquid.
just to a liquid, right? Okay? Like when you get a cold glass of iced tea, or let's say you get a cold Coke at the store, and you get it at a restaurant. What's the stuff that collects on the outside of your glass? You get water, right? Okay? That's from the water vapor in the air that's a gas turning to a liquid when it gets cold, when it gets close to your glass, and then it condenses onto your glass. Okay? So that's condensation. The last one, you can just keep writing. I'm going to erase this because I ran out of room. The last one is sublimation, and you need to star this one, highlight it, something. Because this is a word they like to put on the test because it's big. It's something you don't necessarily learn when you are in 3rd grade. So they like to put it on the test when you're older. Sublimation is going straight from a solid to a gas. Okay? And an example is dry ice. Okay? You guys seen dry ice before, I hope. Okay? Okay, dry ice. Going straight from a solid, it looks like a real piece of ice, but it's really just carbon dioxide. And then as soon as it starts warming up, it starts turning straight to a gas. There's no liquid in between. Okay? So what's sublimation? Going from
Solid to gas.
straight to a gas. What's sublimation?
Solid to gas.
Good. All right. So now, back to chemical changes. Some examples of chemical changes are what? What's one example? What's the easiest one? How about burning, right? Burning. Can you change something back after you burn it? No, you can't change it back. Okay? So it goes, once you burn it, you're left with the carbon, which is the black stuff. Okay? So if I burn a piece of wood as opposed to cut it, can I turn it back to a piece of wood? No. Once you burn a piece of wood, it's done. Okay? It's ashes. Burning. Another example is oxidation. What's oxidation?
Rusting.
Good. Rusting. Right? If you leave your bike outside, the chain on the bike, it starts turning from kind of the metal color to what? Like a reddish color, right? You leave it outside, which is the rust. Okay? You can wipe that rust off and there's metal underneath, but can you turn that rust back to metal?
No.
No, you can't turn the rust back to metal. So oxidizing or oxidation. Okay? And the last one is digestion. digestion. Okay? The way to think of that is food that goes in isn't food that comes out. Okay, so what goes in is a piece of pizza. Does it come out a piece of pizza? No, it does not come out a piece of pizza. If it goes in Gatorade, it doesn't come out Gatorade. Okay? You don't want to re-drink it and tell someone it's Gatorade. It's not the truth. Okay? So when you digest food, it turns it into what two things? Digestion turns it into what two things?
Nutrients and waste.
Good. Nutrients and waste. And then we remember that nutrients go to the what system? Circulatory, and waste go to the excretory system. Okay? So that's back to reviewing. So a chemical change. Can you change a chemical change back?
No.
No. Can you change a physical change back?
Yes.
Yes. Okay? Chemical change is a new substance. Chemical change, you just change the appearance of the same thing. Okay? And what's sublimation? Going from a solid to a gas. Okay? Now, one more word and we are done for today. Alright. The last thing we need to know is the law of conservation of mass. Anyone know what the law of conservation of mass says? Mass cannot be good. Mass cannot be created or destroyed. Okay? So what does that mean? So if I cut a piece of wood in half, did I create any mass?
No.
No. Did I destroy it? Did it just disappear? No. It's just two pieces of wood. Okay? If I start out with a piece of wood that equals 100 grams, okay? And I cut it in half. Now I have two pieces that are each 50 grams plus 50 grams equals still 100 grams, right? After I cut it. Now I have 50, 50, and it still equals 100. Does that make sense? Okay. So, if you see it on the test, it could say, okay, on one side of the equation, if we want to write it as an equation, we have x plus y. On the other side, we're left with z plus w. So x plus y, what are we going to have to put in the middle here? X plus y. If we change x plus y to get z and w, what has to be in the middle? If nothing can be created or destroyed, is a greater than sign?
It's an equal sign.
An equal sign, right? Because x plus y has to equal z plus w in law of conservation of mass. Because am I going to create anything?
No.
Am I going to take anything away? No. Right? Have y'all ever changed something and it just disappeared? No, it never just disappears. It changes to something else. Right? Okay? So the law of conservation of mass. Mass cannot be created or destroyed. Okay? So mass cannot be created or destroyed. Alright.